let's continue. And then we have to calculate the silhouette score for the hierarchical clustering as well. And then we are done with hierarchical clustering. The next clustering that we are talking about is Gaussian mixture model or GMM. So for Gaussian mixture model, you have to again say how many clusters do you want. So here we're going to say we want 3 clusters, and then again we are setting the random state because we want to get the same result every time we run the code. So then again we are using fit predict. Fit will find the patterns and then predict will apply it to the data set. That basically means it will give a label to each one of the data points and say which cluster do they belong to. We are done with the clustering part. I didn't have the silhouette score. I added it here for GMM. Then what we're going to do is, because we want to do visualization for each one of these clusters, right? So these clusters have actually 4 dimension because we had 4 different features. Iris have 4 different features and has a label. 4 dimension is going to be very difficult, if not impossible, for visualizing the data. So what we're going to use is PCA, and we talked about PCA before. It just changes the axis in a way that we would be able to save the most amount of information. Now, when we are using PCA, keep in mind, PCA is going to be different from the actual dimensions that we had, what we calculated here. So that is why we're using silhouette score, and that will show us if our cluster did well or not. But even though we are visualizing it, but you cannot completely trust the way that principal component display, especially because in this code we are using principal component only for visualization. Okay, so now that we created our PCA, so instead of 4 features, 4 columns, or 4 dimensions, now we have 2. Then we're going to create another data frame and put all of our data points in these 2 dimensional space, and only use these 2 principal components. That basically means each one of our data points have a cluster. We're going to start plotting it. So here we are creating a function because see, we have 1, 2, 3, 4. We have 4 different clusters that we want to plot. Instead of writing this whole thing like the way that the plot is done, instead of writing this 4 times, we are going to make a function out of it. Then we can use that function and pass the parameters for each one of these. Now let's run the code. Okay, first let's look at the silhouette score before we go through the visualizations. And the score that is closer to 1 means that your cluster did better. So right now for k-means we are getting 55. It's not really good. And then we are using db scan, which is 65 and or 0.65, or I should say 0.66. And then we're using for hierarchical, we're getting 0.55. So our k-mean and hierarchical are very close. And then we are having GMM, which did the worst here because it is 0.50. And now let's look at the visualization. So the first one that we are looking at is k-mean clustering, and then second one is db scan. Let's look at the silhouette score again here. So as you can see, k-means seem to be separating it better, but db scan getting a higher score. If you remember, I explained that we are not actually using the features or columns that we already have here, but we are using principal component. So the angle that we are looking at these data points are not exactly the angle that they are in their actual columns. Okay, so but the way that we are visualizing it, but from this angle that we are looking at it, it looks like that some of the points are, imagine there is another dimension there. So like there's a z. Imagine there is a z axis here as well. So even though these points are all over each other here, but probably For example, these purple points or black points are closer to each other in the z dimension, and then the yellow ones are farther away down. So even though they look like all on top of each other, like they are mixed together, but in other dimension, if you're looking at it from other dimension, these points probably from z-axis, it's like, for example, you're looking from an airplane down, and then some of these people are standing on top of a building, and these black dots are standing on the ground. So even though when you're looking at them from airplane, it seems like they are all beside each other and mixed together, but some of these points are way higher than the other points. So that is why, even though it seems like DB-Scan did the worst, it actually did the best. Hierarchical clustering, let's see if it is very similar to k-mean clustering. So yeah, k-mean and hierarchical clustering are very similar. And then we are looking at the GMM, the one that did the worst. Well, actually, you know what I'm gonna do? I'm going to change these to just two of the columns instead of using PCA. Okay, the rest of this stuff are similar. We just changed these two columns. Now let's run this again. Actually, I'm gonna close this so it won't. Maybe I shouldn't have. Never mind. So let's just run it and see how they look like. Yeah, as you can see, this visualization is even worse than PCA because when we are using PCA, we are um, not rotating, but change the um, change the position of our columns, or I should say axis, in a way that it would capture the most amount of information. Um, so when you're rotating that with the most amount of information, that means that the rest of the axis do not have as much influence as it has when you're actually using two columns from the actual table mixed with each other again because you have two other dimensions and these data points are actually scattered over in these four dimensions. So we're just looking at it from with using two of the columns. And this is not a correct representation of where the actual data points are placed.